important differential equation questions which have appeared in previous years' NIOS papers. So the first question we are taking is we need to find the order of this differential equation. An order is simply the strength of the derivative, right? So here you can see there is d square y by dx square, which is also known as double derivative or second order derivative. And the reason it's known as that is because here it's the power of the derivative itself is 2, right? So you're gonna get the derivative of this 2x square once, and then gonna get it again, right? So this is double derivative. So the degree here, the order here is 2. And the next we need to find the particular solution of this differential equation. Now particular solution simply means first you are going to have to simplify this into the differential equation form, right, which is dy upon dx plus py equals q, right? Then you're going to compute the integration factor using the formula exponential raised to integration of the integration factors of the formula exponential raised to integration of p dx, and then you're going to put that value that you will get in the final formula, which is y into the integrating function. You simply multiply the integrating function, you substitute the integrating function, right? So what you simply do is you say, okay, y into integrating function equals integration of q into integrating function dx plus c. And once you get the final answer, you will input the values of x and y, and that will give you a value which will be the value of the constant, right, which is the plus c in the end of every integration. So of course we first start with computing it into getting the values from the form dy by dx plus py equals q, which gives us these values, right, which is p is cot x and q is this. Now we simply put this into the integration factor formula, and we derive the integration factor, right, using, see, this formula was used, e raised to log x, right? And once we're done with that, now we're going to substitute everything into this formula. This formula will give us the plus c part which we need to find, right? So once we do that, we put the values as required, and then we begin to simplify the equation. So we take out the coefficient, we add and subtract the numerator by 1 so that we can split it into 2 terms, which will make it possible to solve it further, right? And then we get our values. Now out of this we can solve the right term further, so we do that. We first we will rationalize the denominator, so we multiply it by 1 minus sin x, and once we have done that, we can you can use the formula of cos square x equals 1 minus sin square x, right, to further simplify it. Then we can split this term into 2 parts as such, and then we will get the we will use our knowledge of trigonometric functions to get these values, sec square x dx minus tan x sec x. The reason we are getting these values is because sec square x 1 upon cos square x is nothing but sec square x, because 1 upon cos is sec and sin upon cos is tan, but sin upon cos is tan, but here we've got sin upon cos square x, so this becomes sin upon cos into 1 upon cos, which comes as tan x sec x, right? So this is our, and then we just multiply this 2 coefficient into the bracket. So this is our final equation here, right? So the next thing we're going to do is we just need to input the values of y and x, right? And we already know that in our case y is 0, right? And we also know x, so there's only one unknown left, which is c, right? So this will simply allow us to solve and get the value for c. In this one, we need to find the solution of 1 plus y squared dx. Simply we need to find the solution of this equation. So again, we will first put it in the formula for the differential equations, which is dy by dx which is simply dy by dx plus py equals q, right? It could be a modification of that, which in this case it's going to be dy by dx plus px equals q, right? Because here you can see there's dx by dy, and then here's your x term, so it's going to be px equals q, right? So using that, then you're going to simply compute the integrating factor. So you compared it to this formula, got the values, put it in our integrating factor, right, and simplify it further. Then you put it in our standard differential formula, which is this. Here you've only got a x term. Yeah, so here you don't have a x and y, you have a x variable and a y variable, right? So here you are simply computing the standard differential for our equation, this one, right? So here it says integrating factor equals exponential raised to tan inverse y, and this is the formula. So then again we just input the values in this sum. Because we are searching for the general equation, we are not using the formula we used in the previous sum, which was used to find the particular solution, which is the value of c. Here we're just going to say the equation of this line is tan inverse etc plus c, right? So we're going to have a plus c, which is going to be an undefined constant. So that's why we're using this formula, right? So now you just once you've input the values, you just simplify it further. Then you will, now to compute this further, you need to let tan inverse as a variable t, right? Once you have done that, it will allow you to solve it further, right? Because there's a formula where it says this 1 plus y square can be cut, and once that is done, because dy is simply what, if you put tan inverse y equals d, then this will become dt will become dt into 1 plus y square will become dy, right? So this will allow you to cut this 1 plus y square and leave you with only t into exponential raised to t. And then it's much easier to compute the integration for that. Then you will just resubstitute the value and get your final equation. We'll put that in equation 1, which was our main equation being used over here, this one, which is our main equation, right? And once you put the value back, you will get our final equation, which is the solution. In this one, in this question, what we are going to do is we are going to be calculating the general equation for this differential equation, right? So once again, the first thing we will do is write down the equation and simplify it, right? So here you see you have a negative power right here, so here you can simplify it as 1 upon exponential raised to x. Then you can just continue to simplify it and take out the common terms. Once you have done that, you will get this value where you can just cross multiply dx into the right hand side and integrate both sides. The reason we are doing this because in a differential equation you need to find the integration of your differential equation, right? Where our differential equation is dy equals something into dx. So here you've got integration of dy and integration of dx. As we all know, differentiation of exponential raised to 3x is exponential raised to 3x upon 3. So we get that. Plus c, right? And then this 3 can be cut, leaving you with the final answer.